Custom sorting in Java. Hello everyone. In today's video, we are diving deep into how to perform custom sorting in Java using sort method. We will start with a basic example using the bubble sort algorithm, and then we'll explore how to achieve custom sorting using the collection sort method in Java. By the end of this video, you will understand how to customize sorting to meet your specific needs. Let's get started. So here we have the simplest sorting algorithm, bubble sort, and we will be using it to do custom sorting. Let's take list of integer. We will pass this list to the bubble sort function, which will sort it in ascending order. After sorting, we'll print list to verify the result. Java C bubble sort.java and then Java bubble sort, and we'll redirect the output to output.txt. And here you can see the list is sorted in ascending order. Now suppose we want to sort the list in descending order. What change do we need to make to our bubble sort function? The key change lies in the comparison logic. Previously, we were swiping elements when the current element was greater than the next. To sort in descending order, we will swipe the element if the current element is less than the next one. Simply changing the greater than operator to less than in the comparison statement. So let's run the code again. Now the list is sorted in descending order. What if we want to sort the list in descending order based on the last digit of each number? So basically what I mean to say is, what if we want to sort this list in decreasing order based on the last digit of each number? So the expected list should be something like last digit of 25 is greater than 64, than 34, and 22, and 12, 11, and 90. This is something we must get after sorting it. In this case, instead of comparing the full value of each number, we will only compare their last digit. We can extract the last digit by dividing the number by 10 and getting the remainder. So we know modulo operator gives the remainder, so we are going to use that. Let's implement this and run the code. This is what we got, and let's compare it with the expected output. 25, 64, 34, 12, 11, 90. We got exactly same. What we have learned here is that the core sorting algorithm remains the same, but by altering the comparison logic, we can customize the sorting order to suit our need. This is the reason sort method in collection class simply needs to know how to compare two values. The underlying sorting algorithm remains unchanged. Next, we will explore how to pass the comparison logic to the sort method. Once you provide this logic, the method automatically handles the rest of the sorting process. Let's sort the same list using collection sort. We will be using lambda expression to sort the collection in Java because lambda expressions are a concise way to sort collections in Java, especially when you want to define custom sorting behavior without creating a separate comparator class. Collection sort method can take two forms. I'm going to comment out this code and write here, let's say collections.sort and pass our list. The two forms are one with the list and the second one with list and a comparator. We are going to see both. Let's first see with one parameter. So, collection sort with one parameter sorts the specified list into ascending order according to the natural ordering of its element. This version is straightforward and only requires the list you want to sort. So let's run this and you can see you got the values in ascending order. Second one takes the comparator. You can use a lambda expression to define the comparator inline, making your code concise and readable. One more important point, collection sort uses a modified version of merge sort algorithm. Merge sort is a stable sorting algorithm with a time complexity of order of n log n. Now, instead of calling the bubble sort function to sort the list in ascending order, we are calling collection.sort. We will remove the code to call bubble sort and instead use collection sort here onwards. As discussed, we do not pass value to the second parameter. It will sort the list in the natural ordering of the object. So I have run this and we got the values in ascending order. Let's sort it in descending order now. In order to sort it in descending order, we need to pass a comparator. Instead of comparator, we can use a lambda expression. So this lambda expression takes two parameters which are of same type as of list. So if list is of type integer, these parameters will be of same type integer. Lambda expression expects us to return an integer value from here. So if you want to keep a first while sorting, while we are comparing two values a and b, if we want to keep a first, we must return negative value. While comparing a and b, if you want to keep a first, return negative value. If you want to keep b first, return positive value. If a and b are the same, return 0. So if we follow this, we'll be easily able to sort list in any required format. So let's go back, and as I said, let's try to compare these values. So as we have to sort in descending order, let's say if A is greater than B. If A is greater than B, this means that we want to keep A first. And if you want to keep A first, I have to return negative value. So here I'll return -1. Else if B is greater than A, I'll return positive value. Else if both are same, I'll return 0. Now let's try to run the code. And you can see the list is sorted in descending order. Instead of writing this based on the condition, you can also write the same by writing return B minus A. It will do the same thing. So let's say B is greater than A. This means it is going to return a positive value. So if we return a positive value, B is placed first. Let's say if A is greater than B, it is going to return the negative value. We are doing the same here. If both are same, it is going to return 0. So instead of writing these three conditions, we can get rid of it by writing just one line of code. Let's try to run this. And we have the list in sorted descending order. If I want to sort this in ascending order, I can just write vice versa, and it should sort this in ascending order. Yeah. In case we want to sort the list in descending order based on the last digit of each number. So I can just, we know if we have to sort in descending order, we write B minus A. And if I have to sort based on the last digit of each number, then I can put here modulo 10. Let's see if we get the right sorted list or not. And you can see we got it sorted in based on the last digit of each number. In case the sum, in case let's say there is two values with the same last digit, in that case we want to, let's say, keep the bigger value first, multi-level sorting. In that case what we can do is, so here we have 64 and 34, or let's say if the last digit of two values matches, we want to keep the smaller value first. Okay, so 34 should come before 64 because the last digit is same for both. In that case, how do we handle that case? So let's see here. Let's say if A mod B is equal to, sorry, A mod 10 is equal to B mod 10. This means that the last digit is matching. Else we'll write a separate condition. So let's say if last digit is matching, we want to keep a smaller value first. And if we want to keep a smaller value first, we know we can write A minus B. In the other condition, it remains same. B mod 10 minus A mod 10. Let's try to run this and see. This time it should be sorted based on the last digit, but 34 should come before 60. Yes, and we got it. Same thing happened with 11 and 12. 12 came before 22 because 12 is smaller than 22. So you can keep n number of conditions over here to do multi-level sortings. Conclusion. So by using a custom comparator in collection sort, You can efficiently sort a list based on complex criteria like the sum of digits while maintaining control over secondary sorting rules. This technique is highly flexible and can be adapted for various sorting needs. Thank you.